A piece of cookware, I feel like, is a very tactile, intimate product. I mean, it's something that someone who has it at home is using every day. Their food is touching it every day. And so we're very specific about how we treat that surface. We're only trying to make products that will last forever, that are useful. The process informs its value.
We start everything off with a digital file and we machine all of our own patterns, so that helps us with the design process because we get to live with things for a while. This side would make the mold for the interior of the Dutch oven, and that's the outside.
Among like cast iron devotees, there are two camps, like people who really prefer vintage cast iron from the 30s and 40s, which has very thin walls and is polished super smooth. And then modern cast iron is generally very thick and heavy. So our skillet is sort of a combination of the two camps. It is on the heavier side because that is what cast iron is good at, but then we spend a lot of time smoothing it down.
With the mold making, it's kind of just an attention to detail and a level of practice. So we use a new sand for the very face of the mold, just a mixture of sand with a little bit of resin binder in it to hold it together. New sand is really angular. All those angles kind of mesh with each other and form a really smooth surface. But then the bulk of what we're putting in the mold is reclaimed sand. It basically takes practice how quickly to pack the sand together so that when you pull it off of the mold, it doesn't leave all the letters and the logo behind and things like that. There are a lot of details to the pieces that need hand finishing and need the types of molds that we make. We add a ceramic filter to the gate. It's a little piece of foam, so it filters any impurities that are left over the iron oxide film that forms on the surface of the metal. Being in control of the whole process and doing it at a really small scale, we don't have to compromise on those things. We can make exactly the piece that we want to make. It adds labor and it adds time, but I think that we get the result that we want in the end. We've got a small induction furnace which melts about 200 pounds at a time. The way it works, kind of like an induction stove, this uses the magnetic field to melt the metal down. Cast iron is always an alloy of iron, carbon, and silicon. You can play with those to give it different properties. I think of our raw material as being these post-consumer things. You know, our raw material is a scrapyard full of brake rotors because there's just so much of it around. The temperature is tricky because there aren't very many good ways to measure it, because if you stick something in it, it melts. The way that we do it as we're pouring is to just look at the color of the metal and kind of get a feel for what it looks like when it's ready. And it has to be just right so that it doesn't freeze before it fills the mold up, so that it isn't so hot that it burns into the sand and makes a really rough surface. We add carbon and silicon to it to make it less brittle and less hard, because otherwise we wouldn't be able to sand it down. We've kind of tweaked it over time through trial and error to make the material what we want. Part of the pouring process is learning to pour at the right speed, filling the mold up just fast enough that it doesn't freeze before it fills the mold, and it solidifies in a matter of seconds because it's coming from 2500 down to room temperature. And not so fast that it's creating turbulence and affecting the surface finish. So that's been something that I've kind of acquired over years of doing it, is the temperature and the pouring speed and the angle and everything just right. So after it's cast and cooled down, we drop the mold onto the shakeout, which is a machine that vibrates. let it kind of disintegrate, and it has a series of screens inside to screen the sand into smaller and smaller pieces until it is back into sand grain form and we can reuse it.
After the skillets are cast, we take the surface of the metal down from its rough finish to like a really nice smooth surface. You use different variations of sandpaper until it gets to the fine surface that you want. John and I both come from art backgrounds. It's our predilection. I think by making these things by hand informs so much of what it is. The idea that like you're getting this tool that was made for you, and just that it took a lot of care to do it.
You know, one of the things about a cast iron skillet is that the handle's always too hot to pick up. That was one of the starting points, was to figure out how we could make one that you could pick up.
The heat dissipates through the fork connection, and then there's less mass in the handle also to hold the heat, so it's cool to the touch when you're cooking with it. Has a pretty thick base, so again, it's good at what cast iron is good at. It has this big helper handle to make it easy to maneuver.
We've got the Dutch oven, so our casting is a little bit thicker than a typical Dutch oven. And then on the lid, it has these little pips on the lid, kind of recirculate the moisture inside.
It sort of contains a little climate inside the Dutch oven, and the weight of the lid helps not let that steam escape too.
The other thing we wanted to do with this is cast the handle into the lid. You can't melt it off. It's not going to come unscrewed over time. We worked on a lot of the details of the Dutch oven with longevity in mind. We have kind of two directions that it can go in after finishing, so we can season it or we can enamel it. Both of those things need a surface texture to attach to. We shot blast it with steel shots, just little tiny steel balls, so we give it this kind of micro texture from the shot blaster.
The seasoning has two purposes. On the one hand, it is building up a nonstick layer of fats that adhere to the iron. The secondary function is that it seals the raw cast iron, which is very susceptible to rust. This is the third layer going on. That'll be the final layer. This one is totally raw. We use organic flaxseed oil. It's very high in fatty acids and has a very high smoke point. It's considered a very hard drying oil. It doesn't come up easily with utensils, so we bake them in the oven at high temperature. The fatty acids in the flaxseed oil polymerize and sort of form a link and form a super hard surface. It bonds with the iron, so it sort of adheres and creates a sealant. The seasoning on the skillet is not going to wash out. The seasoning is cooked on, and it's like building meal by meal on like the most microscopic layer. Cast iron is good at maintaining heat. If you heat a cast iron pan up to a certain temperature, it is going to hold that heat. If you get your skillet scorching hot and you put a huge piece of meat in it, the temperature of the pan is not going to drop. It's going to maintain a constant temperature. But a lot of what's nice about it is what makes it a handmade product. The very specific surface feel we go for helps the cooking experience. So when we're finishing, you'll see us touching everything, making sure it feels good. That's one thing that makes our product really nice.
For the enameled pieces, those go on to this other process that we've brought in-house. So this is what they look like before they get enameled. The castings after their shot blast get the enamel slip sprayed on, and an enamel slip is a lot like glazing a ceramic piece. It's a mixture of glass, powder, and clay, and then it gets dried off in an oven. We started working on the Dutch oven probably 3 or 4 years ago. We were hoping to work with the last big enameling company in the US. After 60 years or so, they went out of business. So we decided to bring that process in-house. The hard part has been making the machinery to do it with. It's not something that exists on our scale. So we've done an enameling setup with used components. We got a conveyor from a factory that made car part, and we've added all the rest of it. I clean the enamel off of the lip where the lid meets the pot, because that's typically where a Dutch oven fails. The enamel chips off the lip, and we season that lip because we wanted these to be kind of indestructible. So we worked with the ceramics engineers at our material supplier. The enamel that they developed for us made to bond really well with the iron so that it expands and contracts with the metal rather than chipping off. After the enamel is dried, it goes into the kiln, which lets the glass and clay fuse to the metal and to each other and creates that vitreous coating that makes it easy to use.
The porcelain enamel surface is non-reactive. It still has like all of the core qualities of the seasoned cast iron, but you cook with it differently. And so now our shop is the only U.S. producer of enamel cast iron.
As a family business, it's hard to be stressed about the same things all the time, but we've got a 3-year-old at home, so he does a good job of taking our mind off of skillets when we leave for the day. More and more people are in tune with where their things come from. I'm really interested in being connected to the product all the way through. We try to make things that we're proud of.